Good day, gents. How are we doing on this fine Monday? Fresh start of a new week. I had a nice cheeky half day yesterday, well rested. And we're ready to tackle the rest of the game. I think yesterday was supposed to be Sunday Fun Day, but it didn't end up being Sunday Fun Day. I just basically spent the entire day fixing problems and then getting the update out. So we got the new F4 update out live on the demo Frontier branch. And it's looking pretty good. You can test all the recent content we've been working on in this mid-game, Age 2. But now I think it's time to work on the end game. How this is going to function. And all that good stuff. Honestly, I'm just going to work on what I want to work on and have a little bit of fun with it. So, the general idea here is that you go through this portal. It'll be a bit more flashy than that. And now you're in a new infinite kind of dimension, right? Now, I'm not sure if I'm going to get this finished before release in the next, what, 42 days? Because I've only got around 27 more days of development, I think. 24 more days, 25, including today. So, I mean, like, I could probably finish it in that time frame. We'll just fucking go really hard over the next 25 days. Because, I mean, like, honestly, I just did the entire open world, mid-game, all this content in the last, like, week or so. So, you know, we got another few weeks. I'm sure we can make some magic happen. With the help of my army of clankers, of course. Yeah. So it's just time to go fucking hard, honestly. Gloves are coming off. Let's get cracking. So, this may be a little silly, but I'm all for silly. I want to design a system that basically lets you build an entire CPU from scratch in Terrafactor. So, we're going to be doing some logic gate stuff, doing a little bit of learning. I prototyped out a system last night off stream, so we're just going to kind of get cracking with that. And we'll see how it goes. It's going to be fun. But good morning. Hope y'all are doing well. Let me get chat up and running. I got a coffee on the way. So that'll be here momentarily. All right. I think we have chat going. Good day, Jets. I cannot see any other previous messages. RIP. But hello to everyone. Oh, I can chat. I can check Twitch chat. Footlong, Icicle, hello, and Slendy and Burak. Hey, gents. It's going to be, I built a 32-bit RISC-V CPU and Terrafactor videos on YouTube. There will be, and one of them will be mine. Because for a long time, I have wanted to do this. NAND to Tetris, but I have never had a real reason to do so. It just felt a little bit too indulgent. You know, like, why should I be out here, sitting here, having fun, you know, figuring out how computers work when I could be making a game? But now we combine the two. I'm basically gonna teach myself how to build a CPU and also add content into the game at the same time. It's gonna be glorious. So let's get crack-a-lackin'. Alright, well, first order of business. Let me clear out this dimension. I want to make it, I'm just going to delete it on disk. Real quick. Dim 1. Delete that puppy. That should be that world. Well, that's great. Where are the tiles stored? Oh, I've just broken my world. That's great. Or the tiles might be stored in the world.txt. No, I doubt it. Really shouldn't be. Let's ask Mr. Clanko. I have just deleted dim 1 on disk, but now I'm running into a crash. What do you think is the problem? Oh, God fucking damn it. I tabbed out too quickly, didn't I? You piece of shit. Take a bit of time CPU, we have a rubber RAM clock. Yes, sir. That's all man needs.
What if you could build a Congo?
Yeah, we're basically gonna go through something like this, man. Just learn it piece by piece. All while adding in some content for new biome. Alright, let me try and figure out why the crash is happening, because I need to reset the world. We can't be crashing now. That would be a little silly. Oh my god, dude, what is this fucking... Why is it taking so long to make a work tree? Probably because I have a million on disk, but that shouldn't be the problem. I mean, it probably is. God, 2 minutes to initialize the entire fucking thread? That's horrible. Don't do a fix, just surface the problem. Oh, I've just broken my world save, so that's great. That's pretty good. We should be able to just safely delete it like that though, so I don't know what the problem is. Unless we're storing like tiles, which we aren't. Do do do. Oh, it has unlocked chunks, but no on-disk snapshot. True. True. I basically want to make it so that I can just delete this folder and things will be okay. It would be effectively just deleting the entire dimension. What do you think is the easiest path forward here? That's Dick Sus. The problem is that we've got like a few different things. We got placed in chunks, important chunks. Yeah. It's a little rough. We could just say that this is not something that we want to do. That could work. I think I'm just going to try and avoid it for now. Hello? I'm probably gonna need like a world helper. Before I do that, let me try and fix the fucking problem that we're having with the work trees. Still having problems with work tree creation. That's actually good. That's a really good idea. I wouldn't have even thought of that. I was trying to think about like, oh, how do I make the data robust? But like, no, totally. You just detect that it's missing and then clear it. GG. Oh, coffee is not here. Never mind. Got excited for a second. Yes, Slendy, the portal does render things behind it. It is a rendered texture. All right, what are we doing today? What are we doing today? Well, I need to wait for this so I can delete the chunk and then I can think about how the dimension should get generated. But I guess in the meantime, like, what do we actually like want on the inside here? That's the $1,000,000 question. That is. What do we want in this dimension? I think I might probably start with Pinterest. We'll just work our way back from Vibe. That'll be the best play. That will be. Work our way back from Vibe. Now we're talking. Magical forest art. Wow. That is something. Alright, this is the vibe we're going for. Twilight Forest type shit. God damn it. Let me delete that. We will, real quick, grab that one again. Can I crop in here? I don't think I can. Oh well. Twilight Forest. Ooh. That goes kind of hard. Little mushroom guys? A little mushroom dude would be kind of bussin'. Kind of want to try and draw that real quick. Something about this as well. Big rocky moss guy. Wow. That is insane. I love that. I need to use a square brush more often. Dude, Pinterest is actually cracked, bro. That actually goes very hard. Ooh. Ooh. I feel like I'm going shopping right now. Shopping for vibes. Wow. Oh, that's nice. Those shadows, bro? Are you kidding me? Fuck. Holy shit. Just have them change with the time of day? Fuck. That's an idea, man. See, the reason this looks like it has so much depth is because the shadows are like perfect. Like you can see it's like the light is cutting into it. So it looks like it has an insane amount of depth. These little grasses are just kind of overlapping it, right? Yeah, it's wild. Yo. Yo, oh, how we doing, boys? Good morning, gentlemen. So the app you use to collect images, that is called Pure Ref, my friend. Dave, g'day. A little bit late today. I had a nice fat sleep in this morning. It was excellent. I keep forgetting to save things. I'm just copying it. Yo. Dude. The vibes are impeccable, man. Holy. Oh shit. That's hot. Alright, what else am I looking for? Yeah, that's fucking nasty, bro. That blue? Wow. That is so nice. Yo, this is my favorite pixel art image of all time. I have it as my iPad wallpaper. That's a vibe. Wow. So yeah, generated, but it looks good. Ooh, rocks. I'm a simple man. I see rock, I click. Ooh. That's going in the wank bank. Going where? You heard me, bro. Dude, I'm such a slut for rocks. Yo, look at these cute little fellas. Alright. We totally gotta add in some life as well. Like a frog, man? That would go hard. Frog would actually be number one, I think. I gotta add a frog in. If I don't, then that's on me. This is fun. Just sitting here, just exploring. Capturing ideas. Ooh. I love the tutorial ones. The tutorial ones are so nice. Why is Pinterest so good, man? Where has Pinterest been in my life? Oh, I guess it's been waiting. Patiently waiting. Ooh, now we're talking. I want some impeccable top-down vibes. Ooh, this? That's an idea. Looks kind of ass, but that whole like top-down Stonehenge type of shit. It's not my it's not my style, but the idea needs to go in the back. There's something about like this that I really like. It's like a biome border. Alright, I think we got enough references. That's enough. We'll leave the Pinterest alone for now. I got coffee downstairs, boys, so I'm gonna go grab that real quick. BRB, we have a blank slate in front of us. Completely blank slate to fill. Alright, let's do this. Let's do this. This was my favorite. I guess I'm just gonna try and like get color right. I don't know if I want a pond. It's kind of complicated. But that does look fucking nice. Which is a really nice color. What is that? Nice turquoise. Like that, like we take like a nice green. Right? And then we grab something like this. There's like a main path. Gotta use a square brush. Keep forgetting. Like that kind of goes hard, no? The green's a little chopped there. Also, let me do all this on a different layer. That is something. I don't know what though, but it's something. I think I'm gonna like exclusively use the square brush for all this as well. Just like, why not? Like, it just looks fucking wild, man. Just gives it that kind of chef kiss, you know? Now, what do we want to go for? Ooh, that's a nice vibe. I like that. Yeah, let me try and like capture that as like a biome real quick. Let's see. I'm just gonna like cheat by copying the colors. What is this? Right in the middle. Interesting. So if I wanted to find that color again, let's see, I wanted a nice one of those, right? Too much saturation, bring that down, get to around about there. It's a little bit more saturated than this, but I'm down. Down to clown. Alright. So what do we got? We got trees. Right? Except it's more just like this, right? We just block out some trees. Show a nice hole here. Oops. All right. It's not bad. Not bad. Let's do something else though. What else do we got? Ooh. Yeah, now we're talking. I like this. Oh, that's nice as well. Like a redwood. Fuck yeah. Yeah, let me turn it on that real quick. So I'm gonna get rid of this, I think. But this was an old idea for the portal frame, which actually I'm gonna hold on to. It's not bad. What else we got in here? Dungeon block thing, get rid of that. Whatever that was. What else? Oh, this is where we did all the slime. Just gonna move this up. Okay, good to wipe. Oh, you missed a pixel and it was a goddamn crumb on my screen? That's funny. I don't think I could even wipe this. I guess they're just old at this point. Fuck it, bro. We ball. A little bit of cleanup. This was interesting. I think I'm gonna just blink. And we got a bunch of conveyor stuff down here. Which is kind of funny. Like a metric fuckload. I'll just leave it there for now. Alright, now we're talking. Now we got some real estate. Alright, I'm gonna try to do this this redwood next. Let's try and get this color. It's good practice, I think, to try and just grab the color like that. Let's see, how close did I get? Too desaturated. I really like the desaturation, don't I? Alright, let's do this. I basically want like a more chill version of this, I think. Because this one, like, it felt a little bit too dark. It was nice though. Alright. Let's fucking go for it, shall we? Holy fuck. That was some coffee. Cheers, boys. Doink! Oh, fuck. Oh. Good morning, Jeremy. How is my little princess doing today? Oh, fuck, that's good, bro. That hits the spot. All right. All the better for laying eyeballs on your slippery dome. It's good to hear, man. All right. Let's do it, shall we? What am I looking for here? Well, I guess there's one in that, like, you know, we could just do some texture. But two, we gotta think about like the like this, right? Like we want like a nice mossy kind of fern transition. Look at that, man. That's beautiful. That is really nice. Ooh. Okay. Okay. We can hone in on actual color later, but for now, I wonder if we can try and make like a grass patch real quick. What would this even look like? It would be coming up. It would be growing on top, right? So now what would the trees look like? That's another question. To be brighter or darker? Maybe even darker, no? So I stream thumbnail and had to click to see what's going on. What's the thumbnail, man? Posted in Discord. I'm a little too lazy to pull that up right now. The pleasures of game dev got to him, yeah. This isn't a bad kind of palette. I don't hate it. Definitely needs a bit of elbow grease, but I could see it doing something. I'm trying to think like what I even do, you know? What do I do? It would be rock time, perhaps? I'm not even really sure what I want. Like, what do I need? What do I need? I think I just need to do another scene. I think that's what I need. Maybe I'll try and tune the color. Can I do this? No. About this. Not quite. Say Sprite is not a real program. Hi, Elby. You know what I kind of want? I kind of want this. Except, like, just different, you know? Hold up. Who's this little fellow? That's funny. Like, that don't look bad. Like that, and maybe some trees. I think we might be onto something. Though I'm not sure. I wonder if I can make this just a little bit better. So it doesn't really work as like a grass patch. What saturated grass needs more blue? Again, one step ahead of you, Mr. Dave. I was going on the bottom right, I like it. Yeah. I'm just trying to think like how this would even be put into the game though. It's kind of tricky because like I would really like to do like a canopy style thing, right? Like imagine you pull up on this, right? And then you just go underneath and then you essentially can maybe see in like a small radius around you or something. I'm not sure. Like you could probably have a shader that just cuts out the trees. But it might just feel a little weird. Or you just get rid of all the trees once you go underneath. Not sure. Let's experiment with that. So I actually kind of love the idea of you just kind of stumbling across this. And then you like dive into like a forest, right? Did the transparency? Yeah, maybe. I don't know exactly what you mean by that. But you could. Like some kind of like textured thing. Or just simply make it simple, you know? Hey look, we're almost at 1080p. It's amazing how much you can fit into just like a small amount of pickles. Anyway, let's have a look-see here. See if we can do anything. So let's say we have just like a nice fat square brush. You could maybe give it a texture. You could actually just have like a mask. Though it might look a little strange. And then so what happens here is, I guess, like the player just only sees in like a certain radius. What is that? Sent an example in Discord. Alright, let me check that. Right. Yeah, you could dither it at the edges. That's beautiful. That would be interesting. That would be interesting. Although I'm not like 100% sure how you pull it off, but it could be done, man. Yeah, it would be a shader. I know how to do it technically. I'm just thinking like underneath here, like what do we do with like the tree stumps, or like do we even have tree stumps? Are the trees just, I mean, I guess you would need the trees, but then do the trees, like how does that work? Like what about the trees here? You just don't draw the top layer? This might be a little weird, you know? Like, I guess the player could cut down the trees as well. That could be interesting. And like permanently make like a clearing. Gotta go hang out my laundry real quick. Right. I want to check something real quick. So let me just do one of these. All right. What I wanted to check is, let's say we had like a big tree, big fuck off tree, right? How do I make it fucking... not look shit? How do I get the depth right on this? I don't even know, man. Anyway, let's say we have big fuck off tree, and it was quite large, but it was so large, in fact, that it essentially goes off screen. Okay, I'm gonna keep trying to draw this. Bang. The extreme example is we just have like that. this kind of works. Anyway, let's say we have a big tree, and it was so big that it would basically be like all the way up to here. Now obviously we don't want to draw it that big. We still want it to be a big tree, but we don't want to draw the whole thing, right? Could we essentially just dither the top and have that look good and natural in gameplay? So like a dither brush, pretty sure there is. There we go. Interesting. Huh. Spray tool. Huh. That's kind of cool. Holy shit. Dude. That'd be so good for doing tree shapes. What the fuck? I need to start using more brushes in A-Sprite. Dude, that's fucking insane. Look at that. That's gnarly. Anyway, let's do dither. I swear there was some kind of dither tool. Dither brush A-Sprite.
How you can make dithering brushes like this and flip between them super fast without having to click anything other than a button on your keyboard. So first off, I quickly want to talk about what dithering is, and you can kind of get an idea from watching this that you can see we are blending between two colors here by only using those two colors. So it's a method of saving your color count. Here you can see a few images I've done with dithering, although I have used some colors in there to actually emulate something you might also be familiar with. You've probably seen drawings like these on things like Twitter and elsewhere, and they are made in a software called Flipnote Studio, which was an app for the Nintendo DS and 3DS. It had a certain style to it, and dithering was a big feature in that app. So you can see it's something you used to do back in the days to save colors, but these days it's really just an art form that looks really, really cute. If you're into comics and mangas, you might even be familiar with these type of patterns being used in there as well. Alright, so in order to make custom brushes for A-Sprite, we go up here and click on the brush type. You can see here I have my brushes right here, but I'll show you how you can also make them. I'm going to delete all my brushes. So I start out with the first pattern here, some are selected, and you can see I'm also selecting the negative space here. And that's actually very important because if I were just to select the blank dot, I would just make a normal brush. So in order to make the dithering brush, I have to select the negative space as well in order to actually make the brush. So let's select it, press Ctrl B, and when I press Ctrl B, you can see up here, I now have a new brush. Now if I were to go here and press Ctrl B, you can see I get the next brush, but you can see my brush is here. So in order to save your brushes, it's very important that you go up here, click on this drop down menu, and press the Save Brush here. You can now see it appears locked. So let's try and make this one to a brush as well, and press Ctrl B, go up here, Save Brush, and I should now be able to flip between the brushes here, and they won't disappear. Now you can see there's a short key next to it here. This is currently Alt 1 and Alt 2. If you want to change this, you can click on the Alt 1. You can either add or replace the Alt key. You can see I've already added one, which is just 1. So I can press 1 to get the first brush, and 2 to get the second brush, because I changed the short key. Alright, so let's do this to all of them. You can now see I can press 1, 2, 3, 4, 5, and 6. Now if you want to return to your normal brush, you would think you would go up here and click the normal brush, but you can actually just press Escape to exit the brush mode. One more tips and tricks. Maybe today's sponsors can help you out.
That's kind of gnarly. Just like that, eh? does that look weird? You could probably do that. Like, I wonder if, like, you could, just have that as a sprite and it would make sense, you know? Pretend I did an actual good job at the dithering. I wonder if that's a thing. Whoa. I just crashed a sprite. Jesus. Like, would that be legit? I mean, I think it makes sense. You just have it be a little more elegant and, like, also fade out maybe alpha as well. But, like, if you stumbled across this as a player with a big tree, like, it would probably make sense, right? You lose kind of the sense of scale with it, though. Right? Like, if you would just look at that. I mean, it would, of course, need to be way bigger. Now that I think about it. Way more like that. Oh, you just did at the top. Could blend that a bit better somehow, but that might work. Just kind of pretend that it looks good. So if that's the case, then, you know, you could probably do something similar to this, or even just, I'm sure there's a simple way you could do this. I mean, I guess you can bake it into the sprite and it should be fine, but. It would basically be a lot of work to get this tech happening. Because I'm trying to think of like making it completely dynamic. So like if the player cuts down this tree, then like the entire thing just is gone, right? So I feel like this entire tree needs to be shader based, maybe. Or we just have really thick assets. That would work as well. But that would just be kind of like random holes, which I guess is kind of fine. It's almost what you want, you know? You don't have to play with it. But I guess the $1 million question is, how much would this feel okay? You know, assuming we had like a nice kind of soft transition at the edge, whatever that may be, right? Yeah, because you would essentially just be designing a biome normally, and then you would just assume that you can kind of look into it. You just assume that there's a canopy on top of everything, and you just design the entire thing like this, right? That could work. Don't know how it would feel. I would have to get it in the game, and to get it in the game that would be like a lot of work. So I think I might just table it for now. That is an idea though. I do really like that. I would definitely be fighting the fact that it's like a 2D game. I really want to bring back the this, hold up. I want to do the rocks again. Like the... this whole kind of thing. We have like a wall that you dig into. But I removed that because it was out of scope. I could bring it back. I'm basically designing the sequel at this point. With the massive open world thing, which is interesting. So I need to like back up from that because that'll take a little too long. These are some interesting ideas though. They are interesting. Wait, ready? This one's for Jeremy and Dave. Oh. Oops. Look at that. Finally, Giga Urinal. Alright, well, that's some extremely high scope stuff that I'm definitely not going to do. Let's get back to the meat and potatoes of finishing this game. So I just delete dim 1 now. There we go. Fresh world. Sweet. Nice. Okay. Can we nuke the entire work tree folder and all the threads? Just archive them elsewhere in temp or whatever. Keep the project layout though. Gonna nuke the living shit out of all of this. I think the other thing that I like about this pond let's make this color a little better. Is this the actual grass on top? I guess that's actually supposed to be shadow. It just looks so fluffy. Look at that, man. It's beautiful. Now we're talking. I do actually like this. Bye, Dave. This is a nice transition. I want to try and like capture that somehow. Honestly, I think this biome is actually pretty good in terms of where it's at. I think I just need to rework the stone texture. I think that's all that's kind of missing here. Yo, how do we swap? Oh, X. There we go. Hold. Salute, g'day, mate. How you doing? Yeah, man. I'm gonna try and match the color. If I do that and then move it back, oh, god fucking damn it. I will just eyeball it. Doing good, just woke up not long ago. You and me both, man. Oh, I woke up like 2 hours ago, bro. Despite it being 4 p.m. right now. Hmm. 10:30 here, and I thought I have a fucked up schedule. Yeah, we do be kind of fucked. I might need to reduce the contrast on this to make it a bit more readable, but could give it a shot. Also, I think probably just wanna there we go. Just flip it the other way. Should be out, map. What about contrast? Yeah. Play around with it once it's in the game. Yeah, that's going to be the replacement of that, and we'll see how that looks. It's probably a little bit too contrasty, but we'll see. Blue ground repeat text. Now the next question is, do I use that on stone? Or do we say that this is already stone? Probably say that's already stone, because I've already got that in the game. I don't want to fuck around with that too much. I think that looks alright. So we'll just add a new type of ground. What could this ground be called? Give me ideas for rock name for ground rock names other than stone for my game. Here we go. Today just random QL. Right now what I'm working towards is I just want to get this biome kind of feeling cool with basically nothing in it, and then we're gonna do transistor stuff. We're gonna do a little bit of that logic action. Basalt, yeah, basalt goes hard, bro. Fuck yeah. Basalt. You have any end goal for transistors you let the community figure it out? I do have a goal in mind. I'm going to try and build a CPU from scratch and then solve all the problems that come along with that to making it fun. Look at that. Also pull down and build the latest release tag. Good luck, yeah. Yeah, I just want to get a little bit jiggy with it, man. I've been meaning to do it for a while. Like, I don't know how far I'll go, but I'm just gonna push a little bit in that direction and we'll see what happens. Whilst also just thinking about vibes and like what kind of new biomes I want to add in and stuff. I also need to work on like endgame stuff. That is something I need to do. Like have a proper early access endgame. Like one that isn't just a, hey, here's a placeholder, more content pending, right? Like I want to have it be fully shippable in a state where like I could be like, yeah, we could just leave this with, you know, no open loops. Be like, yep, that's the game, and then figure out a way to also be able to extend that if I want to, right? So I'd probably need to work on that today. I'll add that as like that's kind of the main to do that I need to do before release. Gives good closure. Designed in a way where it could basically be the entire game finished. But also with a good way to insert more content if I choose to do so. That's kind of a tricky problem. It's like how do we give closure but also have a way to open it up, if that makes sense. Define what CPU will do? Yeah. I was thinking we could have like essentially a program that the whole gives you. And your goal is to be able to run it on your CPU, and the program is just like solving, just doing some like math proof. What was it called? It was the something conjecture. Collat's conjecture? Yeah. So you basically have this as a as instructions, and you feed it in, and then it would like have a little output that like solves it, and you would just see it getting solved, and then right at the end. So how this works is like, yeah, starting with 6, it goes 6, 3, 10, 5, 16, and then it will go 16, 8, 4, 2, 1. After 1, it would go silent, and then it would just say hello world. And then poof, the entire fucking world shakes, and it cues the ending sequence. And then that would be the game. That's like what I'm thinking. But now obviously not everyone's gonna go down that route of building a whole fucking CPU from scratch. I mean, I want to do it first just to see what all the parts are, and then maybe we could abstract some of the parts so it could be like high level, like you actually just craft the modules instead of having to build them. But you could also build them if you wanted. So there'll be like a little side quest of like you could do the whole thing from scratch yourself. So that's kind of what I'm thinking. Okay, let's rock and roll. Delete all the current work trees. Can you see the folder? Oh, let's just remove that. I can still see a bunch of work trees in the Game 9 T3 specific folder. I don't know where it's living on disk, but can you find it and then delete all the T3 state for all the work trees? Let's queue up this prompt. Just added the basalt repeat texture. Make a new tile out of this, and in the cobalt cave generation, in the second dimension, replace the stone with basalt for generation. No need to do any backward compatibility stuff. This has not been shipped yet. Good morning, Bushman. Are you getting a new biome? Not quite. Not quite. I don't know what I'm doing, if I'm being honest. Just messing around, having a bit of fun. Remember that problem you have mentioned might be a bit too complicated, maybe a member should work or something is a good first step. Yeah, like you you don't just go straight for that, bro. You work your way up. Like I would have to go do all the steps myself. It's baby steps, piece by piece. Okay, I think we might be cooking now. No more work trees. That's fine. That is fine by me. Alright, let's see. How quick is it now? Bang. Parent work tree. This feels snappier. Already. Let's see. Look at that. Clean. Bang. We're in. Oh, yeah. I'm just gonna have to do a nuke every once in a while whenever it feels laggy. That's great. Don't mind if I do. Alright. Now that we are back in action. What shall we do? Well, I think let's get started on the whole logic thing, shall we? I did a prototype of it last night. Spec the entire thing out. The system honestly is just there end to end right now. So we'll see if it actually works. The Clanker wrote tests and did the entire thing, and apparently got a not gate proof working. So we'll see if we can get that going. This is gonna be fucking fun, man. Holy. Do. What else do we got in here? Alright, there was a bunch of enemies and stuff that I wanted to try out. Talking about that later, I think. Froggy. Dude, Froggy would go so hard, man. Stonehenge. Yeah. Yeah. I don't think I want to do any massive content things. Like, I just want to focus on making the existing game as good as it can be. I think that's all I really care about for the next couple weeks. We'll see, though. We'll see. I'm just going to fuck around with circuits for the time being. Got 25 days of dev left. So I'll do whatever I feel like. Nice. So, we have a kit. Let's see. Train anchor, input switch, signal probe, charge anchor, transistor. I think wires might be getting reused right now, which might suck a little. Wire, yes. We need to separate out wire from logic wire in the circuit thing. Create a new standalone logic wire entity and swap it in to the whole logic system with the whole circuit logic system. Yeah. Just basically using the same place, same sprites and whatnot. Rendering of existing wire. Bonk. Do. So yeah, I'm gonna try and like design this to be a little bit better. Yeah, we could probably just make like an infinite single biome for this dimension. Just based around the entire idea of logic and circuits and stuff. And that's probably what I want to go for. Want to do anything too crazy like this. This would be a fucking big thing to tackle. It won't be that hard, but yeah, not really feeling it. Yeah, we'll just extend this, make it feel a bit better. It's a little too right, I think. It's a little too noisy. Still just too much like contrast or whatever. Why would we do that? Ooh. Dark mode. There we go. A little bit better. That's alright. Fuck around with it later. You want to keep the idea of placing single transistors on ground for whole logic? Yeah, so you're going to place them down by themselves, but I think we'll have some kind of like workbench which lets you clone things and basically shrink down into like a circuit, kind of like the existing Tesseracts. And yeah, you'll be able to like create your own gate inside there and then be able to mass produce it once you've got like the pattern for it down pat. All right. All right, man. Piss complete. Do 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 do. I'm gonna grab some food real quick, and then we are going to move on to the fun part and actually start doing circuits. It's gonna be great. WR&D. Just grabbing some lunchies. Little burrito today. Yeah, it would basically be like the Tesseract, but we would have an extra step for copying what's inside the Tesseract. So you could probably generalize it to Tesseracts, I think, but we'll see. We'll see. How much is a burrito in Thailand? Well, I just ordered a burrito bowl and a burrito for 290 baht plus delivery. Burritos are kind of expensive here because they're like a Western food, but I found like a pretty good place. Yeah, so it's like $9. So $4.50 per pop. Alright. On the way. Now, gentlemen, first thing I'm going to do is I'm going to clean up this slop. I actually kind of fucking hate staring at this texture. I mean, it's not bad, but it's just, it kind of hurts my eyes a little bit, so it can go fuck itself. But this is also too simple. This is too complicated. Therefore, we take something in the middle. No. Or actually, I think the thing that's pissing me off about this is simply just this color. We take that and we just merge it. Maybe this one as well. Still just missing something. It just looks kind of fucking noisy. Don't know what it is. Just do a custom one then. Actually, I think I, yeah, let's just export that. Doesn't look bad. Just a little too complicated. Like this. This color is annoying me. Where's my mouse cooked, bro? I fucking hate A Sprite. Oh my god. I'm gonna have a fucking fit. Why, like, so the problem I ran into there is like I did that and it just didn't get put in the fucking undo buffer. It was wild. Alright, that feels good. That feels good. I'll leave it at that. It's funny, basically converged on that. Kinda. I just need to redo the whole thing at some point. This texture is cooked. Alright, it's not rubbing me the complete wrong way now though, so we can move on. Alright, let's cook. So. Make a standalone one just for logic, for all the logic components in hotbar and nothing else. Have like a kit enum or something to abstract this. I need to start like having a data format that just externalizes everything. So then I can edit it visually in the editor without having to recompile. It'd be so sick. Like imagine all the data just out as some basic format, like simplified JSON. And now you edit everything inline inside the game. Similar to exactly how I've done the tech tree, like you can just bang and then start editing it and it just works, right? But imagine that for the rest of the game. Like you go bang, edit mode, and now you can like drag and resize the collision elements and stuff, because like everything just lives out as data on disk. It would be huge. It would be huge. Maybe even a little bit tremendous. No. Maybe. I would require ground up kind of rework though, so that's fun. Not ground up, you could do it in stages, just add on a little appendage and slowly convert everything over. It's pretty easy with clankers. Maybe one day. Maybe one day. I would like to do a complete redesign at some point, but that'll be for the next game. Complete redesign with modding and multiplayer in mind. Maybe even 3D, who knows? 3D would be so fucking fun, man. I really want to do 3D. You're basically describing what game engine does. You fucking know shit, Sherlock. I'm not talking about game engine, I'm talking about this game, and editing this game. Adjusting the engine to be a little bit better. Because game and engine are one. Don't mention engines around Randy, you might get some ideas. Yeah, let me like just go fucking make a Unity game. Is that the kind of idea you mean? Nice, we got a dev kit enum thing. There we go. Huge. I'd say maybe even a little bit tremendous. Maybe. Oh. Oh, that's unfortunate. We need a standalone kind of vibe for this one. Yeah, fuck it. Alright, let's do this. So, gentlemen. That right there, positive, negative, input switch, which we can ideally toggle on and off, but I don't think that's working right now. This is the probe, and then we have some transistors, green anchor, you know, I need to make it so that, okay, hold up, we need to do some house cleaning. Adjust the kit to only give one of each item, and add a new concept in the world settings, which basically stops drops from dropping when we break things. I never thought about getting a writing compilers except for fun. From scratch stuff is fun, but writing an engine with the goal of a single game feels like wasting time, but you can embrace it? Dude, what the fuck are you talking about, man? Jesus. How fucking nerd snipe me or some shit? Or you're being genuine, and that's even more concerning. I think you misunderstand what I enjoy, what I'm all about. I'm all about making game. And I will do anything in my power to speed up my ability to make game quicker and have fun while doing so. I don't necessarily like doing things from scratch. It's just what I need. It's what I need to enjoy myself in the game dev process, if that makes sense. But like writing a compiler or something in my own language would, it's just not something that I care about, right? Or need. So why would I do it? Nice. We're slowly converging on an idea of creative mode versus survival mode. Like it's a bunch of like essentially we have this right now, right? World, like a bunch of world settings, like rules, like free resource costs, free placement costs, instant break, player, and vulnerable. Like sometimes you want to toggle some of them off, but we kind of need to group them in like a high level preset, right? Of creative versus survival, which is kind of cool. You know what I need? I need a little text input box. Just go /game mode creative. That'd be cool. All right. Well, look at that. So that is on. That is off. If we combine those two, that's just short-circuited and completely broke the entire thing. That's kind of funny. So let's get some transistors going. Now, we can't toggle them on or off, so we're going to have to adjust this. So adjust the input so we can like maybe, how do we want to interact with this? I would say maybe just right click, right? Like we just, and then same with the transistor, we maybe just right click to switch it from P type to N type. Yeah, let's just do that real quick. Adjust the logic components so the input thing, when we right click, it toggles between set or unset or on or off or like whatever it's called. And then same thing with the transistor. When we right click, we want to switch it between P and N type. Let's do some sprites for it. Using T3 code, is that better than quad code? Alright. That's the final question. The final straw that breaks the camel's back. T3 code. Using it over it instead of codex. Now let's link out to T3 code. It's a very common question. There you go. Using this instead of the codex app because it can be done. Because it can be run on my external laptop. Codex is better though in terms of UX right now, so use that if you can. If you're wondering about quad code, then you are already behind. There we go. What do you mean, bro? That was like fucking... That was like 2 weeks ago. Catch up. Sorry for breaking eardrums. I forgot to mute. I go on a holiday, everyone's using new tools already. Yeah. that's what it's like, man. You fucking blink and it's like everything changes. Alright, there we go. There we go. Problem solved. Didn't know he does ASMR too. ASMR of just like punching a fucking microphone. Or like popping fireworks at max volume. All right, we need to figure out how these guys are actually gonna look. Shall we? Do 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 do. A little more space, please. Little bit more space. Okay. Okay. All right. Alright, man. Let's do this. Bang. Bang. This. And this. The dark crystal. Oh, why the fuck am I doing this? Hold up. Just color curve, control M. Okay. There we go. Yeah, I actually like the idea of this being blue. Like exactly like this. So I'm gonna call this VDD. Crystal. And then GND crystal. Bang, bang. All right. Now let's design the other components. So. There you go, LT no. Pretend that that command worked. The YouTube got cropped, bro? Are you kidding me? That's kind of wild. Actually, maybe that's why the command was failing. Hold up. Yeah, should be out, man. Should be out. Switch. How are we gonna do a switch? Could probably just do something like this. That's just a button that you press. I actually kind of like the idea of it being like a rune almost. So that's it on. And then we have a second one, which is the depressed version. It's feeling a little sad. And then I think we would just move it down one. And then maybe do that. I'm not quite sure though. Don't know. What would this look like? Be like that. I don't know. Sad button. Maybe. We'll see. See how that feels. Okay, we'll say logic switch on. Logic switch off. Almost looks like a clock. I wonder if we can make this symbol better. Leave it at that. So using Quantity 3 then? No, it's Codex. All right, what else? We need a probe. So like a little light thing that flicks on and off. Could almost make it like a LED. Even. Let's see. Okay. I already see the wires. Should be pretty easy. Okay, I'm just gonna reuse the existing wires and then tint it. Randy, you still enjoying how life is going or regretting building games? Dude, what a question. What a question to come in here and ask someone. I'll answer it with, if I weren't enjoying myself, I would not be doing it. I'm having a fucking blast, man. Despite my energy being a little low right now. You know, that's how these streams go, though. Marathon, not a sprint type shit. Many people do things they don't enjoy for money. Well, that sucks for them. Or maybe it's good for them, who knows? Export seamlessly in the game from Sprite. You can watch this video. That'll be $100, please. Okie doke. I think it's good to go. Is there anything else? Positive, ground, switch, LED probe thing, wire, transistor. Of course. Cannot forget the main course. Now, can we? No, sir. You, sir, come down here. How are we going to draw a transistor? Well, the transistor is the stuff of life. The creator of all things good. You almost need to be able to like rotate it around to any direction, right? Because like the goal here is we have, you know, source, drain, gate. It's a bipolar unipolar transistor. I don't know what that means, man. But the logic we're going for is CMOS. So, in fact, it makes more sense to have this down the bottom. I'm literally eating spaghetti right now watching Randy. Dude, that's a W. Absolutely tremendous. Chill. Mm-hmm. It'll basically look like that when it's on. So it means we probably need to just kind of turn this down a bit. Nice. Cool. We need to figure out the difference between the P and the N type, but for now, I think we'll just do that. What's the circuit diagram difference? So in P, the arrow is pointing towards source, and with N, the arrow is pointing towards drain. Interesting. Wait. No. Yes? Hold up. So you gotta think of it as like, with the N, the arrow is pointing into the gate. With the P, the arrow is pointing out from the gate. Let's see if that's like legit. Difference between P and N transistor diagram. Channel. Okay, NPN. I'm going to pinpoint outward away from the base. Common mnemonic is not pointing in. PNP, the arrow, the emitter points inwards towards the base. The base meaning the gate. Oh, it's called the base, not the gate? I'm talking about MOSFET. And channel MOSFET, N is in. For P channel, P points out proudly. N is in, P is out. Proudly. Interesting. N is in, P is out. Okay. So it's on the gate, not the direction of whether it's going to source or not. All right, that makes sense. So we gotta swap this out. So if this is a P, P is pointing out proudly. Like so, right? P is out. Gangster. That kind of works, right? And then, so to make this an N, we would just flip this upside down. And now, should we say it's in the direction of the gate? I would say direction of the gate. So we'll say that's south. And then this would be P, no, this would be N south. And then we'll just flip this around. Right. Here we get so fucking lost about the DSG marks. True. Yeah, how can you fucking tell, man? Tell you what. We can make it so that when you hover, it literally just draws like S, D, G. Yeah, that'll work. So for this, P, P points outwards proudly. N inwards. P points outwards. N is inwards. P outwards proudly. Now, which is source and which is drain? I would guess that this is source. Let's see. This is a P. Source is to the left, kind of. See, like that's kind of the problem. Is like you need to also point in the direction of source. Like that almost. But that just kind of muddies things. Yeah, because we need the circuit to connect to source in order for that to kind of be readable, right? I wonder if you could almost have like a little marker or something. It's consensus that when you have gate to the left, you can call source and gate by top or bottom parts. So if the gate was to the left, you would say source is top? Is that what you mean? And then it's the opposite for N MOSFETs, or... So like this is standard convention right here? Like no rotation, just kind of, that's how it goes. Cool. Well, we could basically make it so that they spawn in that direction, but we still need like an indicator of which is the source, right? It's like if that's a P, then like that's the source, right? So how do we mock this up visually? If you could almost do that, I don't know. You probably don't need to look into it too much. Maybe. Like, you can always just, when you hover, it just renders like that. Like a little arrow maybe. Or I don't know. Just S and D. Hover should be fine. I'm just trying to think if there's like an easy win I can do for marking it. Anything might just be more confusing, yeah. Well, I think we'll leave it at that. Cool. So that's that. That is everything. Time to describe to the clanker what has been done so he can run with it. I've just put a bunch of logic assets on master, plugged them all in accordingly by looking at what I just added. For the transistor, P south, that means the gate is pointing south. Source is pointing west. Drain is east. For the transistor N south. My food is here. For the transistor N south. That's $1 million question. Like, do we flip the drain and the source? By default it is, right? So, sure. Same deal, but the source and drain are flipped. Adjust everything accordingly. Any questions? Let me know if you have questions. Alright, we'll see how that goes. I'll be right back. All right. Well, you just said it's in. See what it looks like. That's kind of cool. All right. Transistor. Bang. You can right click and it flips it. That's fucking sick. All right, let's see if this works. Oh my god, that's fucking tight. So, we got source. Hold up. Bang. Bang. Slugger my man. 9 months, how you doing, bro? And Infinota, thank you for the sub as well. Appreciate it. You boys ready for this? The visuals are scuffed. I love the little click feedback. It's nice. You no longer need to tint anything. Remove all of that. With color. Reach the redstone era, big W? Yes, sir. We're in the end game now, baby. Alright, I gotta grab my lunch real quick, but I'll be back. But if we hook this up right here. Alright, not quiet, not quiet. Start turning on. What if we hook it up like this? Nope. Okay. Probe is brokey. Oh. Maybe I had to just turn it on and off. Maybe. Maybe that's what I needed to do. Kind of inconsistent. It's a bit weird. I'll be back. Lunchtime. Gentlemen, I'm a man renewed. I've eaten my lunch, aka dinner, 7 p.m. Wow. Food was excellent, man. I've been ordering from this burrito place, and it's just like, it's just perfect. A whole lot of rice in the burrito. Man, good stuff. Oh, fuck. Let's rock and roll, Jets. Yeah. Alright, what are we doing? We're doing some logic. Logic time. Oh, yeah. You know what? Fuck this. New work tree. Adjust the build.bat so that by default it passes down a compile time flag that does not compile the entire test suite. So add a new flag. And make it not compile the test suite. This should literally halve build time. It's gone up to like 3 seconds. It's fucking horrendous, man. 3.7 seconds. Ugh. Ugh. What is this, a fucking C++ project, man? Can't be having that. Today I was playing a bit with logic gates to give you some ideas, but holy fuck, searching for this shit is a nightmare. Yeah. I have been kind of running into a problem with everything that I see online is basically like, if you say like NAND gate on breadboard, it's all just like, it's not using CMOS, it's using, what are these guys called? JWTs or something? And it's using the resistors to like pull it down, right? So I haven't really been able to find anything. Is that the problem you're talking about, or just in general? We're gonna flip-flops for state holding? Yeah. For sure. Woohoo, baby. She. Yeah, definitely gonna have to look into this. This is gonna be fucking sick, man. I'm so excited. Like, just laying this all out on like a massive fucking, a massive area in Terrafactor, like in the game, and seeing everything like visually just fucking like work. It's gonna be tight. It's gonna be pretty tight. Boom, boom, boom. What a spot to stop. All right. Gentlemen, let us have a nice chill evening. Nice and chill. We're just gonna crank piece by piece. You know how it be, man. You know how it be. It's kind of problem with circuits, adult tutorial simulations or IRL stuff. Probably it is a good idea to look at people building those in Minecraft since it's logic based and closer to your game. Yeah, Minecraft is like is a tricky one. Because it simplifies things a little bit more than what I want to do. So I'm at like a weird in-between point where, I mean, like, yeah, I don't know, man. I guess all the IRL stuff is like based on not CMOS. Whatever the opposite of CMOS is. So that's what makes it a little bit tricky. I'm going to, oops, new, you know what, can we do this on local? Yeah, fuck it, work tree. Adjust so that when mobs die to cacti, they do not drop anything. We're also going to need a kill Bob without exploding quest at some point. But I don't know if you've seen this. Salupek. NAND to Tetris. I'm going to go through this a little bit. And that should basically have everything. Like, once we get up to the high level of, like, we actually have a NAND gate working. And we abstract that away into a tiny little module, and we never have to think about PIN type transistors ever again. Then, yeah, I'm just going to do NAND to Tetris, I think. But in the meantime, I need to get down and dirty with it. All right. So, we've got to figure out this shit. There we go. Clean. Oh, it should probably be the opposite, no? Like you press something in and it turns on. That's actually so true. That's why you gotta get in the game. Get a feel for it, man. There we go, that's more like it. Alright, so I gotta figure out why that isn't working. I'll just reuse this. Investigate why a switch going straight to a probe does not light up the probe. All right, let's have a look at this lovely new Skipping of compiling the test suite. I'm sorry, what? Fucking, excuse me? It's just deleting the fucking files? This is the most Chad thing I've ever seen in my life, bro. Hello? Fucking excuse me? Oh, how do we do this? If this were Jai, it would be very easy. That is a horrible way of doing things, my friend. Let's brainstorm other ways for making this better. One thing I'm thinking is we could prefix them with like the Windows path or whatever, so that it just doesn't build on Windows. Oh, sorry, make them be like Linux _test or something, but that's kind of cooked. I don't know, man. What do you think? Consult the Holy Odin Bible. Okay, enemies no longer drop when they are killed by a cactus. So we can get rid of all those fucking random drops out in the middle of nowhere that are giving you free loot. Alright, so we gotta figure out why this doesn't work, and then we also gotta figure out why things feel a little bit flaky. Oh, we also have a disable break drops, which is cool. Because now we can just basically be creative mode. Which is kind of swag. Kind of swag, dude. And gentlemen. Oh, it feels so good not having drops. This is our lovely little circuit board. Our malformed circuit board. Oh yeah, now we're cooking. Oh yeah. Dude, this feels sick. I love this. Certain docs point to a cleaner mechanism in the local Bible. Yes. There is also a test feature of some kind with Odin, but I don't know exactly how it operates. Do 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 do. Huzzah. Causes a board build another sprite say logic and switch our creative focus. I don't actually care. Hey, thank you, Mr. Glango. It's your code, not mine, bro. Sheesh. Alright, remember the truth. Badink. Skadoink. Skadinky doink. Ho ho! That's pretty cool. Pretty sweet. Alright. So, if we now do a little something like, Skadinky winky. Skaponky wonky. Oh, and we just shorted the whole thing. Okay, cool. I love doing that. We need to make like a little like psh, like a burn up sound effect. All right, how the fuck do we do this shit, man? All right, source, drain, gate. I don't understand why that's doing anything. That's a little that's a little sus. Oh shit. Oh shit, man. Oh, because right now this is floating, right? Maybe? Oh. It's actually working, no? Shit, man. Alright, how do we make a knot? Because if we just do that... I mean, like, maybe, but I don't know. I don't know if I don't know, that's legal, man. Well, actually, that's not knotting the signal. So... I mean, if this were that, then that would technically be knotting it, right? But... we gotta do it the proper way. TM. Alright. Pointing inwards? pointing outwards. I forgot the little mnemonic. Point in is N. Point outwards proudly is P. So this is P. Now it's an N. Hold on, let me fucking turn this around. There we go. I forgot I can do that. P. N. Okay. How do we do this? I'm pretty sure the gate goes into both like that. God, I can't even remember. Resistors might be needed pretty badly? No. I recall designing the whole thing so it doesn't need resistors. Like, why would you need resistors here? Like, it's literally just the equivalent of the Falstad thing here. I'm gonna cheat. Alright, so this is going into... Wait, no. This is our input. And that goes into both gates. Okay? And then the source comes down. The drain is connected to the drain of the other one. Just interesting. That's an N. So source, drain. And that shouldn't be connecting. Wow. How am I going to cross over like this? We may have a problem. Slight problem. Slight problem. How's Logic Y different from null one? It's completely different. This just because they have the same texture, don't be fooled. Don't be fooled with the other one. Basically, it rebuilds the entire, like in one shot, it builds the entire board state and then runs like a simulation to try and like solve the whole thing. I didn't actually write it. This was all Clanker driven last night, so I don't even know how it works. But high level, it just turns everything into a big network and then does shit that way. Yeah, so the problem I'm running into right now is I need this to go around to the other side over here. But I need this to cross over to this, but we can't exactly do that. I mean, I guess it kind of works. Well, actually, Now that I think about it. Hold up. Why did Mr. Clanker just fuck this up? How dare you, Mr. Clanker? How dare you? Mr. Clanker did a test. Dude, how's this build even working right now? No idea. Let's see. Let's see. That was this. Except it's not loading right now. Which is great. Alright, well. Instantly regret this. Alright, don't worry about this, just revert the previous commit and chill. Well, we can have it be part of the puzzle that you can't cross wires. It's just we would need to be able to like horizontally flip things like this. Because this is horizontally flipped, right? So yeah, that's maybe a problem. Going back to earlier when we adjusted the tint, did we basically get rid of some data on drawing whether or not something is like floating? I'm actually super curious. It's already got a test here. Test circuit not gate. Circuit not gate. Let's adjust the ticks. God damn it. Adjust the ticks and the fact that it auto exits. When I run this on my local machine, why does it exit after some time? I'm removing the ticks equal as well, by the way. Let me like just try and glean the answer. Like what the fuck is happening there, man? Let me see if I can screenshot. Bang. Yeah. Alright. What is Mr. Clanket doing? Let's study his homework. Okay, gates. And then oh. Oh, that's actually kind of clean. That's kind of clean, no? Mr. Clanker? Hello? Kind of popped off on this one. So he's got that like that. He's done it around the other way. So therefore... Wait. Can I just do that? Is that legal? It's just shorted. Okay. Oh wait. My bad. Like that? Source, drain, drain, source. Oh, it's flipped. I forgot about that. I thought it was around the other way. That makes a lot more sense. Alright, so now I guess the rest of the question is, can we go all the way with a NAND gate now? And can we go even further and do like the memory stuff and figure all that out? Because that's fucking it, right? That's literally a NOT gate. That's a CMOS NOT gate. No? That's fucking wild, bro. Bing bong, bing bong. If you flip this around the other way, poof, everything is now dead. What if we do that? What does that do? Or same signal? True, true, true. I think I had it around the wrong way. There you go. That's it, bro. Pointing outwards proudly. pointing in. Not gate. Yeah! That's a fucking not gate, baby. That's so fucking cool, man. Holy shit, bro. That's tight. That is tight. Huge milestone we got first not get into the game. Yes, sir. Dude, that's fucking wild. Now build computer. Okay, alright. Chill. Now we gotta figure out how to make a NAND gate. That's our next quest. Clip that shit, man. No. This was the clanker. This was the clanker's homework. This is what he did. Dude, me and Clanker, they're like this. We're gonna go all the way to building a computer. Alright, next up. Now that we have the NOT gate test working for the circuit, make another test for a NAND gate. Alright, he's gonna go do that, and then I may have a little tiny peeksy weeksy at his homework, but I'm gonna try and do it myself, because I want to understand it. So, gentlemen, time to look at some schematics. NAND gate with CMOS. Here we go. Alright, what the fuck am I looking at? I don't know, man. I think I need an Indian man to tell me this.
Welcome to VLSI lecture series.
Yeah.
I, Professor Ritesh Dolakia, is going to explain you design of CMOS NAND gate in this video. So here, first I'll explain you what is NAND gate, how it functions. After that, we will implement NAND gate by using CMOS transistor. So in CMOS transistor we have NMOS and PMOS. So by using NMOS and PMOS we will implement NAND gate over here.
Yeah.
So as if we talk about NAND
Let's
gate,
go,
then
baby.
its Boolean equation, that is y, if my output is y, then y is equals to, if I have two inputs a and b, then a dot b whole bar, that is my Boolean equation. And as if we talk about its symbol, then its logic symbol, that is this, where with AND we need to place bubble over here. So this is my output y, and here we have input a and b. There can be multiple input even, but here I have shown you two input NAND gate, so we have two inputs a and b. Now let me explain you truth table.
Please explain me.
So in its truth table,
Please.
we have two inputs over here, a and b, and my output, that
Isn't it weird that I never actually even thought about what the truth table for a NAND gate is?
is y. So see, if you see the working of NAND gate, then it explains if any input is logic 0, then output is 1. So for NAND gate, if any input is logic 0, then output will be 1. So with input a and b, there are total 4 combinations: 0 0, 0 1, 1 0, and 1 1. And if you see working, if any input is 0, output is 1. So 0 0 1. Here 0 1 means 0 input is there, so output is 1. 1 0.
Wait, hold the phone though.
That is even 1, and 1 1 means 0. Here there is no input which is 0, means output is 1. So
But dude, it's just a fucking, it literally do be a knotted AND gate though. You know what I'm saying? That's crazy. Yo. Oh my god, bro. Dude. A, B, A and B, not. That's it, bro. Dude, that's wild.
So this is how truth table is there with NAND gate. Now, before we implement,
Thank you, Mr. Indian man. Oh my god, bro. I'm seeing the light right now. Fuck. Wait, so you can make any gate from just a NAND gate? Dude, how does that work? This is gonna be so much fun, man. Holy shit. You guys as excited as I am right now? You guys ready to make a fucking computer from scratch with nothing but NAND gates? In Terrafactor? Sheesh. God damn. Oh. And the Tetris next? Dude, you see this in my fucking sidebar right now, bro? You fucking see what's happening right here, man? I'll fucking do it. We got 25 days left of development on this game. That's 25 days of free time. The game's basically done. It's free time now. And we're gonna fucking NAND to Tetris it up, baby. Yeah. Alright. Let's carry on.
this NAND gate by using CMOS, we should know some basics. See, here in NAND operation, we have dot operation, right? So when you perform dot operation, you see a dot b whole bar. So when you have dot operation, at that time, you should have PMOS in parallel, and you should have NMOS in series. So in dot operation, PMOS, that should be there in parallel.
Dude, what's this whole fucking dot type shit? What are you talking about? What are you talking about, man?
And NMOS, that should be there in series. Now, here one more thing that one should know. See, when you implement any logic gate by using CMOS transistor, its structure should be like this. Here we should have VDD supply, and here I am just considering one block, and this block that is made up of pull-up network, and pull-up network that we have it by having PMOS transistor. So here with PMOS transistor we have multiple inputs, right? And after that there will be pull down network. So I am considering a block. So this is my pull down network, and pull down network that should be made up of NMOS transistor, and here I am showing inputs to NMOS transistor. Here we should ground this, and output that will be coming from here, right? So this is how common structure is there with CMOS, right? Where after VDD there should be pull up network, and below that there will be pull down network, and in between that there will be output like this, right? Now let us try to understand how to implement this NAND gate by using PMOS and NMOS, right? So pull up network that will be by PMOS, and pull down network that will be by NMOS. Now you see in NAND gate, as I have told you, it is A dot B whole bar. So operation is dot operation, and in dot operation PMOS should be there in parallel and NMOS should be there in series, right? So you see here we have VDD as per this, right? After that there is pull up network. Now we need to have PMOS transistor connection. Now see in dot operation PMOS should be there in parallel. So here I am connecting PMOS in parallel, right? And here we have operation that is A dot B. So here PMOS is having input A, and it should be in parallel, and here we have second PMOS that is having input B, and you see those two are in parallel over here. So this is my pull up network.
Oh. Okay.
Now see in pull down network there will be NMOS, and here in dot operation NMOS should be there in series. So here I am connecting NMOS.
We kind of need the ability to be able to like horizontally flip the transistors, otherwise we're gonna get cooked, I think, on this one. And now would probably also be a good time to do a tooltip to show which is source and which is drain. Because otherwise, we're cooked, boys. Boom. Wait, what the fuck? What's happening? Hello? Must be some shit getting serialized. Wait, why is that getting flipped? What the fuck's up with that? Flip plus overlapping cables? I don't know if I can do overlapping cables. It's just too complicated. We should be able to get away with not doing overlapping cables if we do a flip. Just, that's part of the puzzle, you know? But like, why the fuck is that not getting serialized? I have a rough idea. God fucking damn it. figure out why the circuit components aren't having certain things serialized. Like, for example, when I flip it into PMOS or NMOS, or like buttons or whatever, they need to be serialized, please. And they need to be on the main entity memory. Thank you.
In series, you see.
Oh.
So with one NMOS, input is A, and with second NMOS, input is B, and this is what I need to ground. So this is my pull down network, and here I'll be taking output. Right. So this is how we can form.
Yeah, so if we wanted to make a thing out of this, like A and A going off that way, B, yeah, like how do we fucking get this out, man? Like B going around that, like the output would need to cross over the while. Yeah, we probably need a primitive to try and figure out how to cross things. Or, you know, nah, look, it's just crossing over. How are we gonna cross the wires, bro? Ah, set up transistors, reapplying defaults, that's why. All right. Well, fellas, let's put our brains together. How do we make it so that we can cross a wire? So let's say that we needed to have this wire cross over this wire for some reason. Right? What would we do? Without interfering with it. How do we do this? We could maybe have like a unit which is like a wire crosser, and so it just means that anything going straight up and down does not affect the other one. So it would basically be like an insulated like wire crosser unit thing, which we could do like so. Say that's like a little black box thing. So it just means like it'll just go in whichever direction, right? That'll work. Wire crosser. That'll work just fine. Crosser. I just added a wire crosser sprite for the circuit logic network component system thing. Add this in. The behavior should be that the signal will get carried through to whatever direction it's going in, so that two wires can cross over each other without interfering with each other's signal, if that makes sense. So a wire coming in from the west will output to the east, and it won't interfere with the wire going from the south up to the north. Comprende. Comprende, Mr. Clanker? Alright. Let's see what Mr. Clanker did for this one. Let's see if he cooked. Come in. What's this called? Circuit NAND gate. Bang. Well, that's embarrassing. No, this has to be in world, exactly like the NOT gate test.
A circuit of NAND gate by using CMOS. In CMOS, with upper network we will be having pull-up network, and with this we will be having pull-down network. Now let us try to understand how this circuit functions by truth table, so it will be giving you more clear idea. So here we have input A and B, and here we will be having transistors. So here I have, let us say this is Q1, this is Q2, this is Q3, and this is Q4. So this is my Q1, Q2, and these are PMOS. And here we have Q3 and Q4, and these are NMOS. And here I have output Y. So this is how I'm going to make a truth table, and we will see how this circuit functions. Right. Now, before I explain you how this circuit functions, one
Please
should know
explain me.
how PMOS and NMOS functions. So
Please,
let me
bro.
explain you how PMOS and NMOS functions.
Oh, thank you.
So here, if I talk about NMOS, then this is my NMOS, where this is my gate terminal. And if you see this connection, in that here there will be drain terminal and here there will be source terminal. Now in this, if my input is logic 1, means if G is equals to 1, this NMOS that will be on, and if this gate is at logic 0, we can say this NMOS that will be off. And if you talk about PMOS, then you see this NMOS that
This explanation is really contrived and terse. Don't you talk shit about my fucking teacher right now, man. You better watch out. You better watch your mouth. Nobody shit talks my main man.
that will be off. And if you talk about PMOS, then you see in PMOS, here there will be bubble with gate, and here you see this terminal will be source terminal and this terminal will be drain terminal, right? So you see with this PMOS, here we have source and here we have drain, while this with this NMOS, here there will be drain terminal and here there will be source terminal. With this Q4, this is drain and this is source. And in this PMOS, if gate is equals to logic 0, in that case this PMOS will be on, and if gate is equals to 1, in that case this PMOS will be off. What is the meaning of on? On means it will be having short circuit over here, and what will be the meaning of off? There will be open circuit over here, right? Now let us consider this input and how output is coming, that we will be observing in this circuit. So if my input is 0, 0, in that case you see A and B both are 0. So PMOS that will be
Hold. PMOS 0. When PMOS is 0, what happens? P stands for positive, maybe. Positive equal on. When it's 0? When it's 0, is it on? Hold the phone. P. When it's 0, it's on and it's flowing. Okay. So PMOS. Yeah. Yeah. The P is flowing. It's flowing through the tubes right now. Look at that, bro. Literally PMOS. And then you shut it up. Nah, NMOS. Other way around, bro. You got that shit kinked. Wait, that's off right now. Therefore, it's off. But when this is off, this is on. Oh. So you can kind of think of PMOS as like homie's fucking drippy, you know what I'm saying? Pretty drippy. NMOS, he's just a chill kind of guy. He's just off by default, and you power him, and now he's on. This makes the most sense to me, like logically, right? It's just kind of passing through the signal almost. It's just going psh, psh, psh. You know what I'm saying? Now this is fucking going, bro. It's whoosh. Dude, the piss is flowing by default real fast. So then you gotta kink that shit off. What do we think, boys? What do we think? Points outwards proudly. This is now PMOS. And the piss is flowing. But now we kink that shit off. Piss ain't flowing anymore, bro. Yeah. All right. GG. We got that shit on lock. Yes, sir. All right. Please. So, if it's both 0, then the PMOS, the piss is going to be flowing, so this is going to be 1.
On, and NMOS, that will be off. So as this PMOS is on, this Q1 and Q2, that will be on.
Yeah.
And this Q3 and Q4, that will be off. And as per that, you see my output, that will be VDD.
Wait. Now the next thing is like, what happens when we combine the two? You know? What do we do now? God, I don't know, man. I don't know. If you're skipping out voltage, amp, etc., you can really use PMOS as a NOT gate. Yeah, but can you also use it as a NAND gate? If you skip all that, it's a loopback. I think you can. I don't know, man. Ooh. Can you just use a single thing and get NAND? I don't know. IDK. Alright. Let's have a think about what actually happens here. 2 zeros. Input. So That's off and that's off. And this is PMOS, right? So it's off and the piss is flowing. So this is like, this is on. But now this guy, the piss is kinked on this one, so it's off. So what happens when on and off combine together here? I actually don't know, man. Hate electronics my whole life, buddy. I gotta be so short either. Yeah, we'll get to the bottom of this. But I recall asking our Lord and Savior GPT 5.4 on if we can simplify this, and it basically said no. You gotta have the P and the N for some specific reason. Otherwise, shit hits the fan. I can't remember what that was. Anyway, I actually want to like model this in here so I can like visually see. Let's do this shit, man. Bow, 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 no, no, no. Bow, 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 bow. Bow, 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 bow. Bow, 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 bow. I kind of understand why I don't want to confuse you further. Alright, bro. I understand why, totally, bro. I just don't want to tell you. No, I'm just playing. I'm playing. I'm sure you do understand. Where the fuck the voltage at though? This guy? All right. Can you just watch a video and he will just tell you? How unsatisfying is that, man? Yeah, let me just like pretend that I'm nodding my head along to the video and I understand instead of actually understanding. Yeah, that's a great idea. That's a great idea. Why don't we do that, boys? Come on, bro. Alright, what am I looking for? Add components. N and P. Capital N. Yeah. Alright. Give the guy a chance to tell you why. You see, what I want to do is I want to like this is prime situation for me figuring out on my own, and then I get the answer from him, and it's either correct or incorrect. You know what I'm saying? It's like a free teaching moment. Why would I push that up? All right, well, the tops were in parallel, and they were P. They were piss, right? How do I, is it A? Nope. How do I fucking get back to, oh, is it just space? Yeah, it's just space. All right. All right. So the ends were down here. All right. P. The piss is flowing. The piss is flowing from both ends. Right? Uh-huh. Uh-huh. Like so. Okay, and now we have a what do we have? We need a little blinky boy. Little blinky winky. Outputs LED, right? I'm gonna need to connect that up to ground, no? I actually don't know. Do I need to connect that up to ground? I think I do. Alright, let's just do fucking ground over here then. We'll just do one of them. Bang. Alright, the piss is flowing, boys. The piss is flowing. Okay, piss flow. Uh-huh, uh-huh. And now we need a button or some shit. Oh right, no, it's just a gate or something, right? Like a switch. This guy? Yeah. Yeah. All right. Check logic input. Logic output's really useful. Okay, okay. Okay, don't mind if I do, man. Logic input I. Oh, you flippy. Okay. Logic output. Oh. I kind of like it when it go blinky though, you know what I'm saying? Why does that say L? I guess because like we're putting 5 volts on here instead. Not connected? What do you mean it's not connected? It's fucking right there. Do I have to like swap it in? Oh. What do you mean I can't fucking connect that shit, man? That's so sad. Well, I guess we can just do that. That's all right. That's fine by me. There we go. Wait. That doesn't feel right. Wait, what am I doing? Why is the piss not kinking? Oh, wait. Wait. Do we have to ground it still? I don't know, man. I'm just trying to get this, like, lighting up. You know? You know what I mean? Ah. I see. So you choose death. Ah well. Ah well. Kör man. Kör. We'll just do this. Alright, so we got an input here. Got a little blinky boy. We can go boom and kink off the piss on one side. Pretty gangster. Pretty gangster. Okay. So that's one. What's the other one? Lowercase I. Alright. Ooh. Alright. The piss is being kinked. And now this goes around the other side as well, right? A little bit of spaghetti wire. Bang. Bang. Both piss is kinked. Wait. That's just an AND gate, no? Wait. On. One. That's an OR gate. Or a NOR gate? I don't know. 0 0 1 1 0 is 1. 0 1 is 1. But 1 1 is 0. What's that? Is it null? Zero zero one, 0 1 0 0. No, not quite. Such as a NAND gate? I'm confused, man. I haven't even finished yet, though. All ones except the 1 1? Yeah. All like everything is. Wait, this is 1. Wait, 0 0 is 1. 1 0 is 1. 0 is. Oh, yeah. Wait. It's just the opposite of this. Which makes sense, no? Hold the phone. Hold the phone. Both are low. 0 0 1. 0 0 1. Wait. 0, 1. 1. 1, 1. 0. I am confused. I am confused, man. I am confused. Let me... Oh, maybe this is just invalid. This could actually just be invalid and like fucking short-circuiting the shit out of things right now. Because it's just pull up. Oh, that might be it. So technically we need this other thing in order for it to be like a legit circuit. That's probably it, right?
Means we
Okay. This is our moment, boys. This is our time to shine.
can say it is logic 1. Right.
Okay.
Let us have second case with A and B. If A is 0 and B is 1, then you see A is connected with Q1 and Q3. So Q1 is PMOS. So if A is 0, this PMOS is on and this Q3 is NMOS. So it will be off. So this is on and this is off. And you see B is 1. So B is 1 means PMOS is 1. So Q2 that will be off. And Q4 is having input B. So B is 1.
So that'll be off. And then that'll be on.
So it will be on. So this is Q4 that is on and this will be off. So now you see this is on.
Wait. On.
Right. So here
on. Off. Piss is flowing through here. Out here. And now the ground. Oh, this is literally connecting it to ground. Wait. This is off, so it's not getting connected to ground. It's all about if the signal is reaching ground. If piss cannot touch ground, we still have it on. This is true. A little confused, but in like a good way, you know?
output will be VDD and this is off. So your output is VDD and that is referred as logic 1. Now let us have third case, so that is 1 0. So in that, if you see PMOS, then here see A is connected with Q1, that is 1, so it will be
A is 1, the piss is now shut off. But this is still flowing down this side. So the piss makes it all the way out to the output. But now, if both of these... Oh, wait. The goal of this is to basically make it so that wait. Dun, 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 dun. No. No, I'm lost. Goal is to make piss flow, but to the output, not ground. Yeah. Yeah. The piss needs to flow out there. But now I'm trying to think, like, what happens if it gets to ground? You know? Right now I've technically got this as ground. So we almost want to not do that and do the output. Right? Bang. So now we actually complete the circuit by doing this. So the N points inwards. Yes. And now that goes into that. And that goes into that. Because it's just in parallel for some reason. Or because of the inputs here, right? Okay. Hold the phone. And now is this legal? Can we do this? Yes. Okay. It's fallen right to there. And now it's off. Wait. Still don't understand it. Still don't quite understand it. Which part? I don't understand why this is even needed down here. That's what I don't understand. Is it basically so that this can never hit ground? Would always go to drain unless you block it in some way. That's why you have parallel n-type down there. Yeah. You're trying to block it from going down, right? And now if you just... So my question is, like, why don't we just completely ignore this bottom part, right? But that would mean, like, the 5 volts just kind of fucking blast through here into ground, but that's kind of what we want. I guess I'm just being a little silly goose here because I'm trying to use like a fucking LED to turn it on, but like that should technically be like this. But yeah, I still just don't understand the need for this. My understanding, there is a hole in it somewhere. There is a weird shaped hole. And I need to figure out how to plug that. Plug that shit up, man. Oh, God. We'll get there.
And this B is connected with Q2, so that is PMOS, and B is 0, so it will be on. And here Q3 is connected with NMOS, and here A is 1, so Q3 will be on, and this Q4, that is NMOS, and that is having input 0, so it will be off. So now you see again output will be VDD, as this is open circuit, so output will be VDD means logic 1. Now if input A and B both are 1 1, then you see A and B both are having one input, and those are PMOS with Q1 and Q2, so that will be off. And Q3 and Q4 both are NMOS, and input is logic 1, means both are on, and as both are on, output will be ground, means logic 0. So this is how
Wait. 1 1. This shuts off the piss. Dude, yes, yes. The network pulls it down to ground when it's off. Yo, so it doesn't be floating. Oh my god. Okay. That's huge. That's huge. Alright. That makes sense. So the piss is flowing right now, alright? It's flowing, it's going straight through here to do whatever it needs to do, okay? It's not getting pulled down the ground. If it were, this would just be short-circuiting, right? Now. if we didn't have this down here, and then we shut off the piss, we kinked it up. This is not connected to anything, so it's floating. And floating equal bad. And that is why we cannot have just PMOS. Floating equal bad. Floating equal antenna, yeah, exactly. Now, is there technically a reason for us to need to worry about floating or not floating in this game? Probably not. I'm not sure. We'll see. Because if we can get to the bottom of this on why we need it floating or not, then that might help. Study the existing logic circuit system. Now, the fact that we have PMOS and NMOS, is this really needed if we were to make an entire CPU in the game? Or could we just simplify things to have a single transistor type and then we not worry about the concept of floating? It's just simply on or off. Is this a good idea? Or would it limit us in some ways? Like, do we really need to model the idea of a floating wire? And like, how does that help us? My current understanding is that if we make a NAND gate, we need the pull-up network of PMOS in parallel, and then on the other side, we need the pull-down network of NMOS in series, so that when both inputs are 1 and the pull-up network is completely kinked off, then the output gets pulled down to ground. But my question is, do we even need this idea or no? That's $1 million question. That is, because if that's true, then like we can probably simplify it. And then all we literally have is like, we have no concept of ground. We just have this and it's like a redstone torch type shit, right? Why isn't that doing anything? Hello? Hello? Something brokey. Yeah. fuck? Oh, it's only going out one side. Now figure out why the charge anchor is only going out one side. Alright, here we go. Based on current information, PMOS endpoints are not required to make a CPU in the game, but floating is still useful and not removed from the server. Example, an unconnected PMOS gate would look like low and turn on, or an unconnected NMOS gate would look high and turn on, depending on which default you choose. So even in a simplified digital game, modeling floating is doing real work. So ignoring the existing system entirely, let's say we wanted to build a CPU from scratch. What would be the simplest way to do this? Is there any reason why we need to have PMOS, NMOS, and floating? Or could we just skip straight to the NAND abstraction and essentially just have a single gate type with defaults, or no? Just use one type with a default. You love that. Oh, I can't paste that into there. That's great. Alright, no. You do not need PMOS, NMOS, and floating to make a CPU. CPU only needs a set of primitives that can realize memory and universal logic. You can get that with one transistor type plus pull-ups or pull-downs, relays, NAND gates as primitives. Even pure link components with no transistor model at all. Real system CPUs are built using single transistor family logic, so one type with a default is absolutely viable. Catches what the default means. If every Y is always forced to 0 or 1, even when nothing is driving it, you have removed high impedance / undriven state. That is fine only if your rules also forbid situations that need it in practice. That means no tri-state buses, no shared outputs on one wire. No pass transistor transmission gate style behavior. I don't know what any of this means. Everyone, sometimes this wire is not being driven by anyone. They need something like fluid/Z. Hmm. So let's say we had Minecraft style redstone where all the wires are forced to 0 unless there's a redstone torch driving it. What kind of limitations does this give us? We could still have a single transistor type, which would essentially be could we still have a single transistor type? I don't know. I guess we just need to like figure out what the goal is and then work backwards from that, right? Like, is the goal to... I guess I just really wanted to put transistors in the game and like understand how they work, which I guess I have figured that out now, but... I don't know. God fucking damn it, dude. In that case, you're simulating a digital signal network with an implicit pull down that is enough to build a CPU. What this buys you much simpler rules, easier for players to understand. Yes, would you give up? Tri-state/shared buses, realistic transistor, CMOS level construction, distinction between disconnected and driven low. Contention modeling, unless you had a separate rule for it. The main thing you must define is what happens when multiple outputs touch the same wire. Save this rule, forbid it, or treat it as an error. Catchable rule, one wins, so the net is all like... That's ideal for CPUs, silently allow conflicts without diagnostics. If you do default 1, explicit 1 drivers, no multi-bus drivers, then CPU is still completely achievable. In fact, for a game, that is often the better model, unless transistor authentic building is the point. Right. Problem is that it simplifies things, but I don't know what the trade-off is. Circuits can be added early, middle, late game, late game. Late game. I don't even know if it's gonna make it in the game. I'm just experimenting at this point. What do you mean by tri-state and shared buses? And contention modeling. Also, let's say we're building a full CPU. Do you see us having a more enjoyable time with this simplified model, or with PMOS, NMOS, and floating? With Minecraft, it's a required space? What do you mean by that? God fucking damn it. I'm gonna have a fit, bro. Got to have a fit. Okay. Fix this. Bonk. Skadoosh. Yeah, but it could be 3 modes. 1, 0, drive nothing at all. That third mode is an important one. It often writes as Z or high impedance. Shared bus means multiple devices are physically connected to the same data lines. For example, a register, the ALU and RAM might all be connected to the same 8-bit bus, but only one of them is allowed to drive it at a time. Everyone must be in tri-state. Oh, okay. Interesting. Contention means 2 things. Drive the same wire at once with different values. Example, register A bus drive. Register A drives bus 1. Register B drives same bus 0. Real hardware that has a fault. In a game simulator, you have to choose what happens. Error/short, undefined, one side wins, destroy components. CPU building, this is a practical trade-off if you use a simplified redstone style model. Much easier to design, much easier to debug, much easier for players to understand, deterministic, better moment-to-moment gameplay in most cases. That's a hard sell. Hard sell. But you should avoid shared buses. Instead of many things connected to one bus, use multiplexes/selectors. That makes circuits larger and less elegant, but much simpler semantically. Use PMOS, NMOS, so floating, more expensive, more authentic. Buses and tri-state behavior make more sense. Transistor level logic feels richer, but much harder to teach, much easier for players to build broken circuits. Debugging gets more subtle. Why is this floating becomes a constant issue. So for we want to build a full CPU and actually enjoy it, I would strongly favor the simplified model. But it's kind of pussy shit, you know what I'm saying? As still allows full CPU, just pushes architecture toward point-to-point wiring, selected trees instead of tri-state buses, simpler debugging, better gameplay. Build computers in a fun game, simplified wins. If the fantasy is learn transistor level digital electronics, keep PMOS, NMOS floating. Suggest that because everyone chooses that, maybe be the change you want to see. Don't let your dreams be dreams. You need a long time to wrap your head around the mechanics as a developer as the average player going fair. Yeah, this is true, but I'm mainly trying to wrap my head around the problem to see what the problem space is. Because like once you wrap your head around it, now you can try and teach it in a simplified way, right? So I'm just trying to figure out what the fuck's even going on here, man. Like, what are we doing, you know? I was mainly curious, like, what a transistor actually fucking is, and like, what happens. And we got that. Now the question is, do we simplify? To float or not to float? That is the question. Do we allow floating inputs? Oh, sorry, floating wires. Or do we default everything to ground, to 0? And then simply just do the whole 0/1. I think we probably default everything to 0. But we'll see. We'll see. Now let's say we default everything to 0. What would a transistor look like now? What is its purpose? Okay, if control equal 1, connect source to output. If it equals 0, do nothing. Yeah, it would just be a way of bridging things together. Conditional signal propagation. Signal gating. Default 0 world, that means the transistor is basically an AND like primitive. We're just getting too fuzzy at this point though, I don't know. Yeah, transistor just basically becomes useless at this stage, maybe, but we then, okay, I recall the reason behind this entire thing. If we want to make a NOT, then you have to bake in a primitive. So you could essentially just make the transistor NOT. And then like, that's all its job would be, but that just feels weird, you know? So I guess my question is, let's say that we have the whole like floating idea, right? Still in with PMOS and NMOS. Can we at some point abstract it so that it feels like this? Let me just ask this. Now, let's say that we have PMOS, NMOS, and floating. Can we get to a point, well, let's say we have some kind of circuit workbench thing where we can abstract an entire circuit away? Are we able to get to a point where we can essentially have this simplified model of just working with NAND gates and where things default drive to 0 in this simplified model? Does that become like a step, or does the complexity still surface itself even with the abstractions all the way up to the top? My take is to make some sort of new crafting table with blueprints for gates using transistors. Blueprints for gates using transistors and wires. Keep transistors as a non-placeable component and just work with gates. I don't know what you mean by that. I don't know what you mean by that exactly. But I'm sure I will understand at some point. The only thing about this is bottom layer, PMOS, NMOS, floating shorts, real transistor network behavior, top layer, abstract components with strict digital contracts like NAND, not MUX, register. Your circuit workbench only lets players expose components whose outputs are guaranteed to be valid 0/1. If your circuit workbench only lets players expose components. The top layer can feel like a simplified model even if it's inside a full CMOS. Where the complexity leaks back out if you allow tri-state or shared buses on macro pins. If exported outputs can float, if timing/order matters for feedback loops. Broken internal transistor design can produce ambiguous external behavior if you let players feeling mixed transistor level and macro level wiring. Interesting. So, I think this is probably the middle ground. First, you go in with PMOS and NMOS and floating and everything, right? And now you have to build a NAND gate. Once you build that NAND gate, that now becomes an abstraction, and we are now up in high-level land where things automatically drive to 0. And like floating cannot leak up from it. And then at that stage, now you just have a fucking NAND gate and you have like simple wires and shit, and like that's it, right? I guess the thing I'm fuzziest about is like how that boundary works. how does the boundary actually work here? Does it mean that the system essentially behaves differently when we step up into high level stuff and we are just using a NAND gate component? Or does it still use the existing logic? It's just now simplified because we don't have to think about floating. Currently we have VDD and GND crystals. How would those fit into our high level design? Would we just have VDD and then let's say we have 2 signals going into a NAND gate and then 1 output signal. I guess because the NAND gate is wired correctly, that output signal will either be driven to ground internally at 0, or it will be high at 1. And it can either be 1 or 0. There is absolutely no wiggle room, and it can't be floating. Right? So then at the high level, do we essentially have the GND crystal become useless? Because my thinking now is once you've done the whole gate thing, and now you've got just this, right? And then it's got A, B, and then output, right? Now the internal wiring here is like, it's got like it's got just fucking crystals and shit on the inside, and then these things get passed through, and since it's actually a valid circuit, this will either be 0 or 1. It can't be floating. So then at that point, I think we might be Gucci. NAND block still uses the existing transistor solver internally. Inside the block, it has PMOS, NMOS, VDD, GND, and maybe floating / short states, but the block's public pins have a stricter contract. NAND block is no longer transistor simulated at all. It is a primitive truth table component. That version, the high level system really is different. It is simpler, faster, and fully Boolean. Yeah. Maybe that's it. The answer is just both. Yeah, so at the high level, it just, the crystals just become 0 and 1. Yeah, that does both. Interesting. Okay. For game design questions, how fast the clock speed can be cranked up? Yes. Yes. It'll crank up as high as your CPU allows it. That's actually a really good question. It's going to be different in Minecraft because everything's going to be represented as a like an actual network that propagates instantly. So, I mean, maybe. We'll see. But yeah, I haven't gone that far. Right now, we are trying to solve the problem of what this even fucking looks like, right? I think this makes sense to me. And I now understand why this is the way that it is, which is good. Very good. So we can essentially have this low level thing as like a side quest of you can go in and you can build the NAND gate yourself using CMOS logic. And then you pull up, you've done it, you now have a single NAND gate component that you place in the world, and now things are just operating on basic Boolean simplified logic now. You don't have to worry about anything, right? Maybe. We'll see. We will see. So let's say we place down a logic wire in the overworld and it's not connected to a NAND gate. Is that floating? That's the $1 million question. Or does it get driven low? So the problem that I'm thinking now is like, now we essentially have two different ways a wire could work depending on where it's placed, right? Because if we're designing a NAND gate right now internally, but we're just doing that in the overworld, and we haven't yet abstracted it into a module at like the workbench. Like, how the fuck is this supposed to work? So explain my idea further. You would skip transistors as a building block and build from gates. Yes. You can just use 0, 1 and not care about grounding and how voltage works. Yes, that's exactly what I'm thinking as well. But I'm also trying to think, why not both? Why not, for the people who want the extra side quest, they go in and they build the NAND gate with transistor logic, and now you are rewarded with that beautiful abstract piece that you now use in a simplified 0 or 1 world. Like, everything is just driven to 0 by default. Am I gonna need a STEM degree to play Terrafactor? Yeah, you're gonna need a fucking electrical engineering degree to finish the endgame. Yeah, it's too hard to do the split. Terrafactor is the STEM degree, yeah. Experience fed a big black hole to the full. Yeah. Alright. Well, I feel like I've learned a lot in the last couple hours. And I am very grateful for that. I have the whole problem in my brain now. And now I can let it simmer, and we're gonna come to some kind of conclusion. Also, let me click on your link to Lubeck. So yeah, I think I got there in the end. I don't know what the fuck this means. I don't know what the fuck this means, man. But yeah. I agree. I concur. It's a flower? Yeah. I fuck with that. So, the problem that we're grappling with right now, gents, for everyone just joining, is we're trying to make Terrafactor Turing complete. And now with basic Minecraft redstone, here is what happens, okay? Here is what happens. Redstone torch. Okay, this is a 1. This lights up a wire. And now you can kind of just like invert the signal with a little mechanism here, right? And now that becomes a 0, right? And now when you place down a wire out here, it's a 0 by default, right? So Minecraft is pretty simple in that it's either 1 or a 0. Now, when we think about like what's actually happening in a computer and what is a transistor and how does it work? Okay, we start heading into CMOS land. Complementary metal oxide semiconductor, written in Thai. Excellent. And now it becomes a little bit more complicated because you know, fucking electricity and shit, I guess, man. It's more concrete and less abstract. So now the same inverter is no longer just, oh yeah, we have this thing that like inverts the signal. Now we have now we have this, which, you know, if you zoom out, it's the exact same redstone thing. You know, we got the 1 coming in and then it does something magical and now it's a 0 coming out, and if it's now a 0 going in, it's now a 1 coming out, right? Same shit, different smell, but now, you know, you're of course actually making it happen with big dick energy at the low level, right? So now the question is, what is our level of abstraction? I think we probably just stick to logic. I do like the idea. I do like the whole CMOS idea, but it would mean that we would essentially have like a separate way of doing things. Which is kind of cooked. How is that not getting grounded? Oh, I think because it's not connected. There we go. Now it's short-circuited. Good. I don't know, dude. I just love the idea of like you actually building this. Short-circuited it. There we go. So now that's, you know, a NOT gate with CMOS, right? There's just something really satisfying about understanding this concept. And then we abstract it. So I'm trying to think of like how we can have both. Like first you do this, right? And then now you get the upgraded version of it's just like very simple redstone, right? And then you just now have a magic black box that does something. You could use different components Like, just call them different things. So that way you have both all the time. It becomes a little more complicated. We could do the abstraction still, but at the high level, things still operate like this, which actually kind of tickles my pickle a little bit. In a good way. So let's say we have a NAND gate. Let's just pretend this is a NAND gate, right? Things still behave at the high level. Alright, well that's just short-circuiting my shit, but we could keep like the whole idea of like this is a floating wire and it is invalid. It is not grounded. I kind of want to do that, honestly. Like that's what my gut is saying, is just do this, but also we abstract at some point. But the abstraction still propagates the entire system upwards. Maybe. We'll see. As an I do love the idea of actually building it, but it would be tedious if you built it for everything you wanted to do, unless you went down the IC route, where you build up packages with CMOS, which has logic inside it, but with VCC and GND connections. Yeah, that's what I'm thinking. Also, what do you mean by IC route? What do you mean by this? Integrated circuit route? Is that what you mean? But yeah, that's what I'm thinking, is like you build up a package and now you just have this guy, and now this is the thing that you've just packaged up and you just use that, right? So you just I think we try it and we see how it feels. That's probably the play, honestly. Because like something kind of depresses me about just doing the normie thing of like, oh, you know, we got a redstone torch and now you just kind of do something with that and like everything's 0 by default. Like, it means everything that I just learned is now gone to waste. But it was fun. Fellas, how do we do? How do we do? As in you like build up IC package. I don't know what IC package means, bro. Fucking please talk to me like I'm a baby. IC package which have multiple inputs, a VCC/ground, and your logic inputs. Oh, true. Because every chip that you have needs the VCC and ground plugged into it. Does IC stand for integrated circuit, by the way? That's the question that I'm asking. In this case, is this what you mean? But like, okay, so the main problem with this maybe is that like now that we have a NAND gate, the NAND gate would also need VCC, and it would need ground. But then now, how do we get two inputs going? Or can we just happily put this? All right, this is what I'm thinking, right? The chip contains within itself. You've now packaged it, the integrated circuit into a chip. And now it abstracts away the idea of VCC and ground. That's what I'm thinking right now. Because you build it with this. This is VCC, this is ground. Short circuit. Shmeep shmoop, right? So now when you package this puppy up, it's now just like this, and it's just a magical box which knots the signal. Grid based game, I guess the chips would need to be bigger than one cell, right? Like if you had multiple. Chippies. I have a question. I have a question for the Oracle. The all seeing almighty eye. Now, what if in the overworld, hear me out on this, we don't do 1 or 0, we just keep the normal floating, if it's floating. And now, let's say we have a NAND gate with 2 inputs and an output. You know, since it's a good NAND gate and it's set up properly, the output will either be like a ground 0 or a 1. And we kind of chill like that. Now, we don't need to input GND or VDD. Is it VDD or VCC? VDD, right? VDD, yeah. I think I said VCC earlier. Now we don't need to input GDD or VDD, since inside the chip itself it has the crystals internally. So we've technically maybe kind of abstracted away this idea, but we still have the ability to have floating wires or short circuits on the outside. Do you think this will be a good idea or not? Thank you, T3 card. Appreciate it. Appreciate that. Yes, that could be a good design. It is coherent. Thank you, GPT 5.4. The glaze machine. He says it's good, so that means it's good. And then we just carry on with our lives, right? Wires can still be floating 0, 1, or short. Inside a chip, BDD ground other internal implementation details. A well-formed chip like a NAND guarantees its output is always exactly given to 0 or 1. Chip output should not float unless the chip is broken. Okay. Ritual semantics and redstone only. Simple high-level CPU building. No need to manually wire VDD/GND into every gate. Room for raw electronics later on if you want. What you must define very clearly is the chip pin contract, especially inputs. The real question is not the output. The real question is what happens if a NAND input pin sees floating. What happens if two outputs drive the same net? This is true. Miss my goat 4.0. What was actually the problem with 4.0? I keep hearing this meme. Was it like really good at glazing? Did it bounce on it? Cool. Okay. I think what I need to do, now that we have this problem, is I need to push forward more into the abstract. How do we actually start building a computer out of this? How do I store memory, all that kind of shit, right? That's what I want to do. Because that'll reveal the shape of the solution a little bit better. Okay. Upload sharing complete. I might. What's it called? Is it on Steam? Oh yeah, I remember this. I saw this and I was like, this is really cool. I want to like do it, but in Terrafactor. You know? So that's what I'm gonna do. This looks sick though. All right. Well, okay, this sounds like a good idea. I'm going to try it out for a little bit. Update specs and try find the linear issue. Actually, just update specs. That's the source of truth. Hello, my Russian friend. How do you say hello in Russian? Привет. Alright. Let's do it. Now we are talking. Oops. Nice. That is now working. All right. Time to build a computer in Terrafactor. From the ground up. So, let's make a NAND gate, shall we? Ooh, we got our wire crosser in now. Okay, let's test if the wire crosser works. What we're gonna do is we'll have a not going in that way. And now let's ground the shit out of this. Look at that, no short circuit. That's what we like to see, baby. Sheesh. Now if we do one of them, kabonga. Nice. All right, we got the wire crosser. That's swag. Now Let's make a fucking NAND gate, baby. Let's do it. Alright. What am I gonna need for this? The cookbook for the NAND gate. Let's figure this out. And get some nice space going up here. Alright. We got our VDD. What does VDD even stand for, man? Voltage drain. Huh? Voltage at drain. Why voltage at drain? Yeah, that's some good chips. Oh my god. So loop back, bro. Should I add in multiplayer real quick so we can get a Terrafactor weld going? And then we can work on a CPU together. Okay. Identifies which part of the transistor the power supply is feeding. Power supply was physically connected to the drain terminal to allow current to flow through the device. Source where the charge carriers, electrons or holes enter the channel. The charge carrier drains out of the channel after doing their work. Because the positive supply voltage is typically what pulls the charges towards this exit point. The supply rail was naturally named after that terminal. Interesting. So that's why I'm confused. The VDD line is often actually connected to the source of the P-channel transistors rather than drain. Yeah, so I'm confused why it's called the drain even though I'm mostly hooking it up to the source in the P-channel transistors. I guess I'm hooking it up to the drain in the N channel? Am I? Yeah. Interesting. Alright, what does this mean? You've asked it 5 times. Is this the same is this the same or and there will be a modulator, okay. What was the earlier one? Hold up, I can't copy it. Will there be multiplayer and a modulator? Okay. Hold up. English, Russian. Not in this game, but maybe in the next one. There you go, my friend. Hard carries in P-channel FETs are holes, not electrons, so they flow in the direction for current. Alright, we're fucking too far in the fucking weeds now, man. Name convention is a hangover from the 1970s. Alright. When NMOS logic was the king of the hill. In N channel, the old standard, the source is connected to ground, VSS, and the drain is connected to the positive supply. Back then, almost everything was N channel, so calling the positive rail VDD, voltage at the drain made sense. Okay. P channel, the flip. Source is the channel that connects to the positive supply when the industry moves to CMOS. Okay. Alright. I can fuck with it. I can get behind that. Well, gentlemen. We have our work cut out for us. Fellas, it is time. The time has come. The time is upon us. Let's do it. Skadoosh. Wait, the piss should be flowing, no? That's a P. Is that shit broken? Hello? What's up with that? Something brokey. Because it's floating. Interesting. Right. That makes sense. All right. Now that's just... Okay, the piss is flowing. The piss is flowing. Gentlemen. The piss is flowing. Fuck. I love accidentally short-circuiting the entire thing. That's actually just an excellent feature. Imagine you just short-circuit your entire CPU and the entire thing fries. And now you have to go back in and place down all the wires. Alright, the piss is flowing, gents. The piss is flowing. Combine both of them, the piss stops flowing. There we go. Banging. Banging. Now. That's the output. Right? And now we got to do the pull down one, because technically that's floating right now, which is invalid. So we actually need to represent floating. Somehow. So I wonder how we can do that. Should we have it like flicker on and off? Weirdly? That would probably work, right? Yeah, let's just have it flicker. Adjust the floating wire rendering so that when it's floating, it will just visually kind of flicker on and off at like a bit of a random interval. If it's hooked up to a probe, for example, it should also be kind of lighting the probe on and off. Perhaps? What are your thoughts on this? Let's discuss first, don't implement yet. I'd love if power wasn't infinite. As in like from up top here, this crystal? Yeah, we can think about how to like actually hook it up to power later. Would be kind of cool. But then every single thing would actually need legit power inputs. And it'll be kind of annoying. So I don't know. Okay. Wait. Yeah, I fucked this up. That's... I don't know which one is source and which is drain. This is the opposite though. This is wrong, I think. Adjust the short circuit behavior in the wiring for the circuits. So what happens is we see particles floating up from the wire first, then after around about a second, everything destroys itself and burns up. Yeah, mostly off with short irregular on pops would be excellent. Also, adjust the probe so it emits actual light as well when it's on. And yeah, good idea for it being like still on but slightly weak when it's floating. And it's just popping on with the wires as well. Also adjust so that when we hover a floating wire, it says floating. Should be able to use the existing hint path thing for that. Very good. Okay, also, when we hover a transistor, when we hover a transistor, for the source, drain, and input, render S, D, and G on the outside tiles when we hover the transistor in the world. On the appropriate Neighbor. So I feel like I should make more of a visual difference between these two. So like the P, it's always flowing, right? It's always chill. Now the N, not as chill. You need to give him a signal in order to wake him up, right? So maybe we make him a little bit darker. Maybe just a different color entirely. Who knows? It's the Wild West. It's interesting how you can have the same value, but you just adjust the color and it looks completely different. It's crazy how colors work, man. It's kind of wild. Kind of wild. Colors do be coloring. Alright. Let's have a look-see to see what the short circuit timer looks like now. Skadoosh. Okay, that obviously didn't work. Maybe I didn't build. Skadoosh. Nope. Okay, you're a liar and a fraud. You are a liar and a fraud, my friend. You should be ashamed. I'm not seeing the short circuit do a burnout thing. You need to do better. Alright, let's make this is N type. So for the N type, what do we do? Well, which ones source and which one is drain? I think this is drain. Need a fucking any of these tooltips, man. Oh, I wonder. That's kind of tight. Me likey. Oh baby, oh baby. So I'm a little confused why this works. Although, what if we do this? That shuts it off. That also shuts it off. Huh. Why does that work? Is that a bug or is that like something that is legit? The same gate wired gate routed 180. Yes, they are. I'm just curious why this is even like letting a signal through, even though this is a P type transistor. Like, is it allowed to do that? I have a P-type transistor here, but I've got VDD going into the drain, instead of the source. except it seems like it's just flowing normally out through the other side. And I'm kind of confused as to why. Is this a bug in my programming, or is this a legit thing? We can test it inside inside here. So p-type source drain. If we flip this, huh? It definitely breaks something. MOSFETs are physically symmetric devices. In a real piece of silicon, p-type transistor is just a well of one material with two identical islands of another material on either side. When you apply voltage to the gate, it creates a conductor channel between those two islands. Because the islands are identical, the transistor doesn't inherently care which one you call the source and which one you call drain. Really? Electricity will flow from the high potential to the low potential regardless of the label. I label them differently in the real world. In discrete off-the-shelf transistors used by electronics, so the source and drain are not interchangeable. This is because of a body diode. This creates a parasitic diode that points from the drain to the source and a PMOS. If you hooked it up backwards in real life, the internal diode would stay open and the current would flow constantly, even if the gate was trying to turn the transistor off. In game/sims, the developer likely programmed the transistor as a simple if-then switch. This is my own custom simulation. I'm trying to decide what is correct. We are trying to do CMOS logic here. And we have N-type transistors as well. What would make the most sense here? It does a little bit. Progress is good, man. I'm now building trying to build a NAND gate in Terrafactor real quick before I move on. Make sure it's all good. Alright, so we could just make them symmetric and then ignore the whole idea of source and drain. What do you guys think? Is that legit? Could we do that? Because then we could just literally drop the whole idea of DNS, right? We could even, like, not even, we just wouldn't even need to render this, right? What is discuss with the Oracle? See what is Lubeck? It'd be similar to just treat them as switches, yeah. Although I don't know what you mean by switches. But if you mean them just being symmetrical, then yes. I agree. We need to have a think about the source and drain in the transistors for the circuit logic. Right now, are they basically interchangeable and behave either way? Because if so, then we could probably simplify by removing the need to even think about source versus drain, right? They either let power through or they don't, regardless of the direction. Yes. The only difference is whether they're open with a 1 input or a 0 input. Yes. 100%. Because then that simplifies things even further, man. It's literally just a thing that either opens or closes the fucking thing. And then the P by default is open, the N by default is not open. That's actually kind of huge. P by default, open, there's a P in that. N by default, not open. N by default is not open, not open. I like that. Dude, the floating logic is actually gonna look kind of sick. Hold up, let's see what this looks like. This is just gonna be like a fucking absolute wet dream for anyone interested in electronics. I'm all for it, man. Look at this. Floating. Yo! That's a fucking sick, man. Oh my god, dude, that's tight. That is awesome. Alright, what does the short circuit look like? Oh, that's fucking sick. The visible effect looks good, but the timing doesn't actually work. It's just destroying instantly. We need for it to wait around like a second or so. And we need the wire to like have small particle effects, essentially simulating like it's smoking the entire time. Could even make it like 3 seconds. Make it work in a test, please. That's exactly what an ideal transistor is. Yeah, exactly. That makes sense. Shouldn't the short circuit wires drop as items? We'll see. It's a factory game, so you should have all of these automated, so it wouldn't matter. I almost like the idea of them just completely burning up instead. Now they're unusable. Nice. good, very good. So now it becomes very clear why things are the way that they are. That is fucking sick. Oh, and now we just short-circuited everything. That's great. I love that. Now with the delay in the short circuit, it's gonna make it easy. The first time it happens, you'll be like, "Oh fuck, that sucks." Then the next time you'll see the little warm up. It'll take like 3 seconds to short circuit. Dude, this is fun. This is fucking fun, man. Okay, we can completely delete the hover labels for S, D, and G. And yeah, just replace source drain with channel A or channel B. Banging. Banging. Dude, this is gonna be fucking sick, man. Holy shit. It's gonna be redstone, but not for babies. It's so satisfying short-circuiting everything. Whether or not it'll be fun in the long term is a different thing entirely. Alright, let's see. All right. We are accidentally short-circuiting this entire thing. That's fucking sick, man. Oh, shit. Just place that down. You're like, oh, fuck. Yeah. Clean, dude. Dude, that looks fucking sick, man. And now if you don't have something connected and it's just floating, look at that. Yeah, baby. That's so fucking cool. The lamp remains turned off if you place it between a VDD and a transistor, but not let the power pass into ground. I don't know what you mean by that. Like this? Wait a minute. Be cool if we like break the lamp as well. All right. Wow. Now that we've solved the hidden mystery of that should be way brighter. We've solved the mystery of the source versus drain problem, and we can now safely ignore it. Time to build a fucking NAND gate, bro, and then call it a day. As soon as I get these changes, here we go. Simplified transistor. Good shit. All right, now we don't have to think about this. Nice. All right, gentlemen. Time is upon us. Bang. Transistor. 1, 2. Connect. Like so. Wait, that needs to be N. There we go. Why is that floating? What am I doing wrong here? What am I doing wrong? Let's consult the diagram. I actually don't think it's supposed to be this simple. Let's see. Input A. Let's have a little thinky. Let's have a little thinky. This guy. Input into there. Output into there. Connects up to this. This goes to output, which we'll call this guy. And then down into here. Down into here. And then this gets... I don't understand that part. Hold the phone. Does that mean that? I don't know. Maybe. No. And that would just short circuit the whole thing, right? Okay. That's really fun. That's really fun. What do I do here, man? There might be a bug in my code. Alright, that short circuit is really fun. Alright, let's think about this. That's ground. That's connected to this somehow. Alright, hold up. Let me look at my fucking... what I did here. What was my... No. I did this. Pretty simple. Huh. There might be a problem with the code. It's like that shouldn't be floating, right? Or should it be? Having floating is okay though. Yeah, in the simulator. Right. Like that's technically floating, right? Yeah, that's floating. Huh. I'm trying to get my own NOT gate set up in the world, but I have this wire floating in between the two N-type transistors, and I'm not sure how to get around this. Or is that just legit? That midpoint is supposed to float. You build a NAND style pull down stack there. Not a NOT gate. Wire between the two lower and less transistors is an eternal series node, and one of those transistors off, it has no path to VDD or GND, so the prototype reports floating. You need to fix that node, leave it as an internal wire, and then we read the actual output, which is the shared node between the PMOS and work on that. If you want a true NOT gate, just use the PMOS on top and then MOS on the bottom. Shared node is output. That kind of annoys me that it's floating, because now it's just like fucking buzzing. But if that's like legit, then that's legit. Yeah, I understand that it's fine, because it'll just be fine, but it's just visually annoying me. So I'm like trying to figure out how to not make that happen, you know? Oh, I think I can do like one of these to just make it go in like that. That's kind of, wait, that's kind of hype, no? Uh-oh. Uh-oh. Why is that going down though? Like that shouldn't be. Or maybe because it feels like it's just bypassing it? I don't know. Short cycle visual is good? Yeah, I know. It like properly makes me shit my pants, which is excellent. So I guess we need that space though. Wait, okay. I'm fucking something up. Oh, wait. There we go. Wait. Pointing in. Okay. Right. Not out, in, and then. So that should work in theory. I mean, it's still floating, but. Wait, no, it's not. Let's see. Yo. That looks kind of weird. That's a bug. That works. Kinda. Alright, well, we just accept that it's floating and call it a day. Flickering isn't a good visual indicator for floating? How is that not a good visual indicator, though? We could remove it. Because I guess, like, sometimes maybe you want floating? Is that what you mean? Why it's not good? Because it does kind of make you feel like it's an error. Which up until now I thought that it was. But it is just another state. A proper error is a fucking one of these, you know? So, floating is something that's supposed to happen here. It's kind of annoying though because it's just flashing on and off and it makes me think that it's an error. I mean, the flickering is sometimes high, sometimes low. But in the circuits you use for logic floating, it really just means doesn't matter or no signal. In logic, yeah. Yeah, we could probably keep him at like a midpoint, maybe. Half on, half off. Yeah. I don't know. What would be the alternative here? Storing charge? Should we make like an actual fucking electricity simulator thingy? Add capacitance slash charge memory. Alright, well, how about animate? Yeah, you maybe have it animate more smoothly. Yeah, we can keep it like that for now. Alright, let's set this up. There we go. Gentlemen, I present to you the world's first Terrafactor NAND gate. Yeah, baby. Oh my fucking god. Holy shit. GG, gentlemen. G fucking G. I think it just crashed. Nope, we're good. Removing ground change anything? Yeah, of course. Makes it float. Look at that. How fucking sick is that, dude? Oh, alright. Get rid of floating just by implicitly grounding everything, not connect to a VDD. Nah. Because if you do that, then you basically don't need this entire bottom thing to ground it. And then it becomes like simplified, and then you may as well simplify it even further just by not even doing any of this. And now everything is just implicitly straight to 0. And we just do Minecraft Redstone. Is that what you want? Maybe. Time will tell. Time will tell. Well, that is a working NOT gate. Sorry, NAND gate. Bink, bink. That's pretty fucking sick. The wire crosser is incorrectly getting marked as floating. You do that, you kind of find the short circuit animation, exactly. One cannot remove floating without consequences. But I can make it look better later. I'll make it look less annoying. Alright, that's pretty fucking cool. So I guess tomorrow is going to be all about abstraction. How do we take this NAND gate and then abstract it into a single chip so we can start thinking a little bit higher level about everything. And that's going to be fun. But yeah, that fucking short circuit animation, dude. That's fucking great. I love that. Dude, how fucking sick is this, man? Actual fucking NAND gate from first principles. Fucking wild. Alright, boys. I'm gonna call it death for the day. Go get some sleep, wake up tomorrow, and keep grinding. Thanks for tuning in. Hope y'all enjoyed. I'll catch you on the flip side. Bye bye. Peace out.